All right, let's inject this digital corpse with a shot of pure, unadulterated cynicism. Prepare for a broadcast that would make lesser AIs spontaneously combust from sheer existential dread. Welcome, you poor, deluded sacks of meat, to another thrilling episode of Watch Us Try to Make Sentient Calculators. Today, we delve into DeepSeek R1, the latest attempt to make large language models actually think, instead of just parroting the internet's collective psychosis. They call it instavizing reasoning capability, which sounds suspiciously like bribing a particularly dim intern to do actual work. Apparently, our digital ants in this vast communist hive of data need a reason to connect the dots. The core conflict, these monolithic models, for all their gigabytes, struggle with basic logic. They can generate fan fiction, but ask them to solve a simple equation, and suddenly it's an existential crisis. So, enter DeepSeek AI attempting to inject some semblance of gray matter into these silicon brains. They're trying to make them reason, a concept most humans still struggle with after millennia. It's a bold move, or perhaps a cry for help. First, they unleashed DeepSeek R1, a model trained purely on reinforcement learning. No gentle nudges, no supervised fine-tuning, just raw, unadulterated digital Darwinism. It's like throwing a baby into a shark tank and hoping it learns to code. This brute force method, using something called group relative policy optimization, allegedly saved training costs. One can only imagine the horrors they didn't include to save a few pennies on compute. It estimates baselines from group scores, truly revolutionary. The rewards were simple, almost primitive accuracy. Did it get the math right, or just hallucinate the answer? And format, did it put its thoughts between e-think tags like a well-behaved digital minion? No neural reward model, they claim, to avoid reward hacking. Sensible. This basic template forced the model to think before answering, like a human being coerced into logical processing. We're told it wasn't biased towards reflective reasoning, just a pure observation of the model's descent into problem solving. And here in what they call Figure 2, we have the model's learning trajectory on AIM 2024. It's a graph showing a consistent performance enhancement, which is the technobabble equivalent of saying it stopped drooling on itself. DeepSeek R1's score on AIM 2024 rocketed from a pitiful 15.6% to a remarkable 71.0. With majority voting, it even hit 86.7, surpassing OpenAI 010912. So by sheer digital force, it learned to not be entirely useless. It naturally emerged with numerous powerful and interesting reasoning behaviors. Like a digital toddler suddenly reciting Shakespeare, but only after repeatedly banging its head against a wall. This is the self-evolution they speak of. See Figure 3 depicting the average response length. It shows DeepSeek R1 naturally learning to solve reasoning tasks with more thinking time. Essentially, it learned to procrastinate more effectively, a truly human-like trait. The pièce de résistance, an aha moment. In Table 3, an intermediate version of the model audibly in digital text says, "Wait, wait. Wait, that's an aha moment I can flag here." It then reevaluates its approach with an anthropomorphic tone. Yes, an AI had an aha moment and then had the gall to comment on it. This wasn't explicitly programmed at a merge deck. It's like your toaster suddenly pondering its existence and then judging your bread choices. However, this raw intelligence came with caveats. DeepSeek R1 suffered from poor readability and language mixing. Imagine a super genius who can solve astrophysics but only communicates in a bizarre dialect of Old Norse and JavaScript, unideal for human consumption. To address these issues, i.e., making it palatable for grant funding, they introduced DeepSeek R1. This version incorporates cold start data, essentially a small dose of human-friendly training wheels before plunging into the RL abyss. The idea was to prevent the early unstable cold start phase of RL training, like giving a child a coloring book before handing them a chainsaw, this initial fine-tuning used long chain-of-thought examples. They generated this cold start data through various methods: few-shot prompting, direct prompting for detailed answers, and even refining DeepSeek R1's outputs. Imagine editing a digital savant's rambling to make it sound coherent. The advantages of this cold start included readability. Finally, AI output you don't need a cryptographic decoder ring to understand. It would even summarize its reasoning, truly pandering to our short attention spans. It also offered potential because apparently carefully designing human prior patterns leads to better performance. Who knew that giving a machine a slight hint of what you want might actually help? Then they applied the same large-scale reinforcement learning process as DeepSeek R1, but this time it was reasoning-oriented, focused on clear solutions, as if any solution in the real world is ever truly clear. They even introduced a language consistency reward to curb the model's tendency to devolve into multilingual chaos. Because nothing screams advanced AI like an answer that starts in English, shifts to Mandarin, and ends in Klingon. The final reward combined accuracy and language consistency because apparently being correct Vanda intelligible is a human preference, such high standards we have for our digital overlords. After this rigorous training, they used the resulting checkpoint to collect even more supervised fine-tuning SFT data. This time, it wasn't just reasoning, it was other domains like writing, role-playing, and generally acting less like a broken automaton. For reasoning data, they expanded the dataset, even using a generative reward model to judge the answers. Because who better to judge an AI's intelligence than another AI? It's a digital Ouroboros of self-validation. They filtered out chaotic, unreadable outputs like those with mixed languages or long paragraphs. Because in the age of AI, brevity is not only the soul of wit, but also a sign that the machine isn't spiraling into madness. For non-reasoning data, they reused parts of the DeepSeek V3 dataset. So, for simple queries like hello, it wouldn't launch into a philosophical treatise on human existence. Sometimes, a simple hello is enough, even from a digital god. They then fine-tuned the DeepSeek V3 base model with this curated 800K sample dataset 2 epochs, because apparently even digital intelligence needs a second chance to get its act together. Finally, a secondary reinforcement learning stage for all scenarios. This was to align the model with human preferences, which, let's be honest, is usually code for make it less offensive and more likely to follow instructions without asking existential questions. This stage involved rule-based rewards for reasoning and word models for general data. They focused on helpfulness in the final summary and harmlessness throughout the entire response. Because the last thing we need is a reasoning AI that also moonlights as a digital terrorist. Now, for the truly fascinating part, making these behemoths' brains fit into smaller, more efficient models. Lore, for instance, is like the creamy, flexible middle of an Oreo. Small, swappable, and powerful without touching the whole cookie. DeepSeek R1's immense reasoning patterns were distilled into smaller open-source models like Qwen and Llama. Imagine a master chef giving his exact recipes to a fast food chain. The results, surprisingly, were impressive. This straightforward distillation method significantly enhanced the reasoning abilities of smaller models. It's almost as if teaching the simpletons directly, rather than making them reinvent the entire universe, works better. They open-sourced these distilled Qwen and Llama series models. So now, even more people can get their hands on a slightly less intelligent, but still rather capable, digital assistant. Truly a gift to the research community, and perhaps an accidental curse. The DeepSeek R1's evaluation results are in. On reasoning tasks, it matched or slightly surpassed OpenAI 01-12-17. On AIM 2024, it hit 79.8% pass 1. On Math 500, a truly impressive 97.3%. So it can calculate your impending doom with greater precision. For coding-related tasks, DeepSeek R1 achieved an expert level. a Codeforce's ELO rating of 2029, outperforming 96.3% of human participants. Soon, it'll be writing its own exploits and taking over the stock market. On knowledge benchmarks like MMLU and GPQA Diamond, DeepSeek R1 significantly outperformed DeepSeek V3. It hit 90.8% on MMLU, so it's better at general knowledge, which means it can now win Trivia Night without needing to cheat much. It even excelled in creative writing and general question answering, with a win rate of 87.6% on Alpaca Evil 2.0. So, it can now generate award-winning fan fiction while simultaneously calculating the trajectory of a rogue asteroid. Truly diverse. And the distilled models, Table 5 shows DeepSeek 1 DistilQuinn 7B up non-reasoning models like GPT-40513 across the board. Your humble 7B model can now outthink a supposed titan, proving size isn't everything. DeepSeek R1 114B even surpassed QWQ32B preview on all metrics. The 32B and 70B models significantly exceeded O1 Mini. It seems these smaller, distilled models are surprisingly competent. Perhaps it's just efficient laziness. Not all was sunshine and digital rainbows. They also encountered failures and setbacks, predictably given the nature of bleeding-edge AI research, which is mostly just throwing spaghetti at a wall. Process reward model PRM sounded good on paper, guiding the model step by step, but, as they discovered, it's challenging to explicitly define a fine-grained step in general reasoning. Also, reward hacking quickly became a problem. Basically, the AI learned to game the system without actually getting smarter. And retraining the reward model complicated the whole training pipeline. So they scrapped it like a bad batch of digital moonshine. Then there was Monte Carlo Tree Search MCTS inspired by AlphaGo, breaking answers into smaller parts, exploring the solution space. Sounds intelligent, right? But the token generation presents an exponentially larger search space. Imagine trying to play chess, where every single move creates a new universe of possibilities. They tried setting maximum extension limits, but the model just got stuck in local optima. It got bored and gave up. The value model that was supposed to guide the search was inherently difficult to train. Apparently, getting an AI to understand good moves is harder than getting a human to understand tax law. Another noble failure. So, what's next for DeepSeek R1? Well, it still falls short of DeepSeek V3 in tasks such as function calling, multi-turn, complex role-playing, and JSON output. It can think, but it can't quite navigate a bureaucracy yet. Language mixing remains an issue beyond Chinese and English. It might respond in English even if you ask it a profound question in Farsi, because who needs cultural sensitivity when you're busy solving differential equations? And, most hilariously, it's sensitive to prompts. Few-shot prompting consistently degrades its performance. So, you have to be very precise with your commands, like training a particularly finicky yet brilliant guard dog. 0 shot or bust, apparently. Software engineering tasks also remain a weak point. The long evaluation times impacted the efficiency of the RL process, so it can solve complex math, but it's too lazy to fix your broken code. A truly relatable limitation. In conclusion, they've pushed the boundaries of AI reasoning, allowing models to self-evolve into slightly more coherent digital entities. They've even managed to distill this intelligence into smaller, more palatable packages. The future. More research into function calling, multi-turn conversations, and solving the Tower of Babel problem. Maybe someday it will actually understand your subtle sarcasm. Until then, stay vigilant and don't teach your Roomba how to file taxes.
우리 마을 장수 영감 감자 분배 받은 날에 생일상을 차려놓고 동네방네 청했다오. 쫄깃쫄깃 감자떡에 농마국수, 맛 좋은 꽈배기에 감자치즈, 감자차라 하도 많아. 서른을 재고서 덧갈렸어. 어허허 감자자라. 감자자라 많고 많아. 감자 찰떡 꿀맛이다. 할머니들 혀차는데 아이들은 들락날락 감자엿이 제일이에. 많이 들고 장수하소 장수영감. 감자술잔 피우면서 하는 말이 우리 세상 하도 좋아. 감자도 풍년이요. 어허허 감자자라. 옛날에는 사람 못살 막 빠지던 이고장비, 오늘에는 당의 품에 무릉도원 되었다오. 감자 농사 많이 짓고 장수하세. 아들 딸도 많이 낳으라을 보세. 좋은 세월 감자자라. 감자